Hi guys, welcome back to my channel. Today I'm going to talk about hierarchical clustering. So it's an unsupervised machine learning. Unsupervised machine learning means what is to be predicted is not known. So we'll group the data points or data objects based on the similarity. In other terms, we say grouping unlabeled data points based on the similarity. So here the clusters are created based on predetermined order from top to bottom or bottom to top. So there are two methods involved in that. So they are agglomerative and divisive. So we'll see the difference between these two. So this hierarchical clustering is similar to no, you organize files in your computer system, like organizing the folders and files in the hard disk. So that is the best example for hierarchical clustering. So there are two approaches in hierarchical clustering. The first one is agglomerative. This is also known as bottom-up approach, wherein each observation has its own cluster. That means if you have 100 observations, so 100 clusters are created. And then based on the similarity, so based on the similarity or based on the characteristics, you can group the clusters. So the step 1 and step 2 are repeated until there is only one cluster left, one big cluster left. So that is why as you group the observations to the big cluster, so that it is known as bottom-up approach. And the other method is divisive method. As the name says, so initially you are having a single cluster, and this cluster is further divided, so based on the similarity. So observations to a single cluster, and then partition the clusters to two least similar clusters. So the cluster division is continued recursively until there is one cluster for each observation. So it is opposite to the agglomerative, and it is known as top down. Means you initially having a single cluster and then you divide them. So that's why it's known as divisive or top down approach. Next we need to understand how the clusters are formed. So here we have four methods. So first you need to determine the proximity matrix, which contains the distance between each point using the distance function. You can use Euclidean or some other distance metric to find the similarity between the points or between the clusters. So the matrix has to be updated, so based on the forming of clusters. So the first method is single linkage, means the points of the two clusters are not defined, means cluster is formed based on the longest distance, sorry, based on the shortest distance. You see this point and this point, so they are close together. So based on the shortest distance, the two clusters are formed. Okay, here this cluster is denoted by R and this one is denoted by S, and based on the shortest distance, so these two clusters are linked. So this is an equation, linkage on R and S, which is equals to minimum, D means distance between the points, and the second one is complete linkage. So this is opposite to single one. Here the two clusters are defined based on the longest distance. You see this point and this point, so they are longest, and the equation for this is L of R comma S, which is equals to max of, means maximum distance between the 2 points. And then average linkage means the average of all the points are considered. So you can see the sum of all these distances and then taking an average of two clusters, NR and NS. Then word linkage, so this is quite optimistic, and this is very common. You try to optimize the cluster formation, and the idea behind this is similar to the ANOVA analysis. Means that the linkage function specifying the distance between two clusters is computed as the increase in ESS, which stands for error sum of square. So the error has to be lower when you are forming the clusters. So these WORD methods try to choose the successive clustering steps so as to minimize the increase in uh, error sum of square at each step. So these are the four methods. So widely the last method is used because it try to optimize the performance of clusters. And here you need to learn the terminology, that is dendrogram. So dendrograms are like a tree structure, similar to the tree structure, which illustrates the arrangement of clusters produced by hierarchical clustering. Here you can have different clades based on the formation, based on the similarity. The clades that are close to the same height are similar to each other. You can see, uh, for example, these two clusters are similar, okay, because they are having a similarity. And the clades with different heights are dissimilar. For example, this clave and this clave, so they are dissimilar, means there is no common attribute. If the points are having common attributes, so they are put into the same cluster. So like this, the dendrogram is formed, and you might be knowing what is the iris dataset. I have also introduced this iris dataset in my previous sessions. So iris is one of the important data set, right? It is one of the important data set, and it's about the flower. So there are three types of flowers: um, setosa, versicolor, and virginica. And by having a dendrogram, the benefit is you can try to know the optimal number of clusters. So first you have to plot a dendrogram, and by plotting a dendrogram you can determine the number of optimal clusters. So these are the steps involved in agglomerative clustering. So at start, treat each data point as one cluster. As I mentioned before, 100 points means 100 cluster. So this is the point to be noted. The number of clusters at the start will be k, while k is an integer which is representing the number of data points. Then two data points are now joined based on the similarity, which is resulting k minus 1 clusters. Again this process is continued. Next step will result k minus 2, k minus 3, k minus 4, like that. So this process is repeated until one big cluster is formed. Okay, one big cluster is formed. So this is agglomerative clustering, bottom to top. So once a single cluster is formed, then the dendrogram are used to divide into multiple clusters. They divide into the multiple clusters. So there are different ways to find the similarity between the clusters. So here you can use Euclidean, or you can also use Manhattan distance. So in order to demonstrate this concept, I'm going to take an example here, sample example. So we are using matplotlib, so importing matplotlib and also importing NumPy. And if you know the basics of the Python, these libraries, matplotlib is used for data visualization, and NumPy is used for creating a multi-dimensional array. NumPy is used to create ND arrays, n-dimensional arrays. So I'm importing these two and then creating an array here. X is equals to np.array. So these are the points. So totally 10 points are there. So the shape of this is going to be 10 by 2, 10 rows, 2 columns. So this is 2-dimensional. I'm displaying the values of x. Next, I just want to show the points using scatter plot. So labels, the labels is equals to a range of 1 to 11. So always, as you know, range start from 1, so always it is going to, by default it starts from 0. So here we are starting from 1, and range always gives 1 point less, so that means up to 10 only. And we are specifying the figure size here. So figure size is 6 by 5, and subplots adjustments based on the bottom margin 0.1, and plotting a scatter plot here. So plotting the values of all rows, 0th column, all rows, column number 1. This is the label of the point. And next we are also annotating the points, right? So for label x comma y in zip, zip means combining these label, x-axis value, y-axis value, and then plt dot annotate means beside the point you can see the label. Which point is that? Either 1, 2, 3, 4 up to 10. annotating the label, specifying the x-axis, y-axis, and at which place the point is displayed. So this is the place -3, 3, and the text record is like offset points. This is HA, means horizontal alignment, right to vertical alignment is bottom, and then plot is shown. Now we can see our 10 points. So annotation gives us the labels. So these are the 10 points 1 to 10. So I have also used the same example in the previous class for k-means clustering. So here the possibility is you can have two clusters by grouping this, or you can have on one more cluster by grouping the top 5 points, or else uh, you can also group these labels 5 and 9 into one cluster, and bottom 4 into one cluster, and top 4 into the another cluster. So if you want to know more about this particular function annotate, you can take help. So plt dot annotate, then question mark means taking help. So when you run this, you'll be getting the description, and you can also go through the meanings of the parameters. So as we have seen, so we can also go for dendrogram. So dendrogram is imported from this module scipy.cluster.hierarchy. You're also importing linkage, and here I'm using the linkage single, and range of the labels 1 to 11 means up to 10 only, specifying the figure size, and having a dendrogram. We're plotting the values on linked orientation is top, labels or from label list, distance or in descending order, so leaf count true means it also shows the count. So when you do this, you can see how these 10 points are grouped. So how these points are grouped based on the similarity. For example, 8 and 7. Where is 8 and where is 7? So here. So as they are closer, so they are into one cluster. Similarly, this one 5 and 9. Okay, 5 and 9. So they are closest. You can see this middle two 5 and 9. So they are closest. So that's why they are into one cluster. So like this, based on the distance, so the clusters are formed. So this figure is known as dendrogram. So by plotting or by having a imaginary line, you can determine the optimal number of clusters. So I'll show that with meaningful example. So once you determine the optimal number of clusters, you can give that number of clusters is equals to 2, means I want to have 2 clusters. So importing agglomerative clustering from scikit-learn.cluster, creating an object, number of clusters 2, affinity means distance metric is Euclidean, and linkage is ward, and then we are making the prediction for complete X. So this gives us the assignments. So we are creating 2 clusters. So last 5 points, last 6 points are into 0th cluster, first 4 are into the cluster label 1, and even you can see the cluster labels individually. So this is a predefined variable labels underscore. It is giving us the label for the 10 points. Then we can also have the scatter plot based on the cluster label, and you can also use the color map. Color map is rainbow. So you can see bottom 4 points into one cluster, and this top 6 points into another cluster. So there are 2 clusters. So in order to understand this concept more, so let's take an interesting example, customer segmentation. For any business organization, it is very important to understand the customers. So we have a data set which is downloaded from Kaggle, and for that data, let's do clustering. So importing pandas and importing matplotlib. So no need to import library multiple times, because as we have already imported this matplotlib in the above cell. So importing pandas and matplotlib, and this is my data, shopping data I kept in my data folder. So specifying the path. So I hope you guys have the basics, how to load a CSV file, how to specify the path, physical path, and then head means by default it displays first 5 rows. So these are the first 5 rows, and what are there in the data set. So there is a customer ID, gender is there, age, annual income, and spending score. Now you can consider the attributes from the data set and you can do the clustering. So importantly, if you think logically, age is also important because the younger people do more shopping than the old people, and annual income is also important. So if you are having more income, then you can spend more. So based on this, spending score is there. So we will be considering these two, annual income and spending score, as data in the sub data frame. Next, I am checking the shape of data. So we have 200 rows and 5 columns. Then we are doing some data exploration here. I am trying to do univariate analysis, means understanding the single variable. So specifying the figure size here is 8,5, and this is the title of the figure, annual income distribution. The font use is 16, and this is x-axis label. So these values are in $1,000. K 1000 means $1,000, and score is in between 1 to 100. So on x-axis we are showing the income, and y-axis you will showing the frequency. So and grid true means you'll be having the square boxes, and having a histogram here on annual income. The color is orange, the edge color equals to K. So then this will plot a graph. You can see from this graph who are having more income. The income, the people who are having the income between 50 to 80, so they are spending more, the frequency is more. Okay, majority of the people are having the income between even you can consider from 40,000 to 80,000. Similarly, we are exploring one more variable here, spending score. The graph is similar. As it is numerical, we are going for histogram. So spending score distribution. So 40 to 60 people. Majority of the people are having the score between 40 to 60. So that is the no, what this graph is showing us. Majority of score between 40 to 60. So we are considering these two variables, annual income and spending score, and then we are doing clustering. And also we are having this regression plot from Seaborn. This is x-axis. On x-axis we are showing annual income, and y-axis you are showing spending score, and data used is clustered data. So that's a data frame name. So this is a regression plot. So by looking at this graph, so do you see any correlation here? So this line, so if you look at deeply, so it's not a straight line. Okay, it's not a straight line. So there is a little bit positive relation. That means income, if income increases, then spending core also increases. It is not a 100% straight line. So here also we are representing then, and then age and spending score. What is the relation between these two? So we are having a regression plot. On x-axis showing age and y-axis showing spending score, and there is negative correlation. That means if the age is increasing, then the spending score is decreasing. As I mentioned before, younger people do more shopping than old age people, so there is negative relation. Now we want to do the clustering here. Then what is our strategy? So first we have to select columns. Which columns here? 3 to 5. 3 to 5 means not 3, 4, 5. It is 3 and 4. Means we are selecting annual income and spending score and subsetting the data. So data equals to, from the original data frame, I location means integer location, selecting all rows, and columns are 3, 4 dot values. So values are assigned to data, and on this data we are having a dendrogram. So from this dendrogram you can determine the optimal number of clusters. So here is the plot. You see the points. Totally we have 200 customers. So based on the income and spending score, we got here the clusters. So this is the cluster. Now the importantly, how to know the optimal number of clusters. So this is a strategy here. Look for the longest stretch of the vertical line, this one, longest stretch of vertical line, and then vertical line which is not crossed by an extended horizontal line. Vertical line should not be crossed by an extended horizontal line. Here extended means horizontal line means which the cluster dividers are extended infinitely to both directions. Now take any point on the stretch line of the graph and then draw a imaginary horizontal line. We have to draw a imaginary horizontal line and then count how many vertical lines are crossed. Okay, how many vertical lines are crossed? That is nothing but the number of clusters. Okay, number of clusters. Now we are drawing a horizontal line on the dendrogram. So this is the uh, code for that. Horizontal line, y-axis 190, x minimum is 0 to 2000, line width is 3, line style is dash dash, and we are also having a text horizontal line crossing the 5 vertical line, and for that we specified the font size also. Look at this line. So this is the line, and this is imaginary horizontal line. So after plotting this imaginary horizontal line, you need to count the number of lines crossed. So 1, 2, 3, 4, 5. So there should be 5 clusters. There should be 5 clusters. Now you might have a question, what if I draw this line little bit above? Then you are missing this. Okay, we are violating this rule. So by considering these rules, you have to think of imaginary line. So by this graph, we can see the number of optimal clusters. As we have already known the number of clusters, so again we can use we can do agglomerative clustering. So imported from scikit-learn.cluster, then creating object to the agglomerative clustering, and these are the parameters. Number of clusters is equals to 5, distance metric is Euclidean, linkage is WORD, making the prediction for complete data, and the predictions are stored into the YHC. So y underscore h is user defined variable. So these are the predictions. 200 samples are assigned to how many clusters? 5. The cluster labels are 0 to 4, means totally 5. Now we are setting some criteria here. So we want to label these 5 clusters. The criteria is careful. Careful means the people who are having high income but low spend. They have high income but they spend less. So we are calling them as careful. Then standard means middle income and middle spender. And target group means we have to consider the people who spend more, whose income is middle to high and high spender. So they have to be targeted by the particular uh, mall, particular shopping mall. Understand? So here we are having a figure, plt dot figure, specifying the figure size here. Before that, there are also other two categories. Careless means they have low income but high spenders, and sensible means low income and low spenders. So we have to target these people who can who are having middle to high income and do spending more. So based on this, we are having a graph here. We are having a scatter plot. So first specifying the figure size, scatter plot 0 0 0 1. Okay, we are getting the points, and this is the width, then color equals to red, and we are labeling that as careful. Then standard means 1 1, 2 1, target group, careless, sensible. Okay, based on the clusters we have formed 0 1 2 3 4. So we are having the scatter plots, and this is the title of the figure: segmenting customers. X-axis income, y-axis is spending score, specifying the font size for legend, having a grid of true, also having a color, background color here, y minimum value 60, maximum is 100, x minimum, x maximum, alpha, color is yellow. Now you can see the graph. So try to understand this figure. So who are these people? These people are having low income and low spending. Low income, low spending means sensible, as we have categorized here. Low income, low spending means sensible. These people. What about these? These people are okay. These people are having low income. Okay, low income but high spending. Okay, low income, high spending is careless. And this one middle income. This one middle income and middle spending. And this one is high income but low spending. They are sensible. What about this middle to high spending? The income is middle here, middle to high, and spending is also middle to high. So this is high spending. So you have to target these people because they are having a no middle to high income and they spend more also. So the shopping mall has to be targeted on these customers so that they get more benefits. So for any business organization, it is very important to understand the customers. So who are coming frequently, right? And who are using their services very frequent. So they have to target those people only so that they can have maximum selling of their sales. So this is the customer segmentation. So in this session, I try to explain what is hierarchical clustering. So remember, there are two methods in that, agglomerative and divisive. Divisive is not widely used, but agglomerative is very important. So agglomerative means bottom to top, right? So you should also know what is dendrogram, and by using dendrogram, how do you determine the optimal number of clusters. So once the optimal number of clusters are known, then you can build a agglomerative model, and using that you can make the predictions. So that's it from me today, and if you have any queries, do reach us. You can comment us, and do subscribe our channel so that you will be getting updated videos.